Hello students, welcome to the day 19 of the 45 days crash course. We will do the rest part of the chemical kinetics. We have already seen order, molecularity and rate of a reaction, and we've also seen the integrated rate law for a zero order reaction. Okay, so we'll move further. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. So, what are the remaining topics for today's class? For that, we'll start from the differential and integral form of different order reactions. So, our remaining order of reaction are first order and the second order. Then we'll move to Arrhenius theory, which is basically telling us about the dependence of temperature. So right now we are dealing with the dependence of concentration. And at last we have this collision theory, which is basically based upon the collision thing. So molecules do react due to the collision that they go through. So we will study about them, and there are also other factors besides collision. So starting from the differential and integral form of zero order reaction. Oh, sorry, yeah, first order reaction. So zero order, we have seen it yesterday. So what is this first order reaction? So in this first order reaction, what we do is that we take the rate law such that the power of the concentration of the reactant is taken as 1, or the change of concentration term of 1 only. Okay, so same thing is given here in terms of your language, that what do you do? That you take the concentration raised to the power 1. So this can be said with the help of example. Suppose we have a reaction going from R to P, where R is the reactant, P is the product. Then the rate can be written as minus dr by dt. Again, I am writing here the differential rate law first of all. So this negative sign denotes what? That denotes that your reactant concentration is decreasing. Dr by dt is equals to Kr. So this is our overall rate law. This K is the rate constant and R is the what? Concentration of the reactant, and it has a power 1 because this is a first order reaction. Now if you just integrate this equation, so you bring this R here and cross multiply this dt with k. Now if you integrate this, then what it will give? It will give you ln r, okay, or 2.303 log r. You can say either of them, and then k dt will integrate to t. Now if you integrate within proper limits such that the initial concentration is a and the final concentration is a minus x, then you will get this equation where time is going from 0 to t. So same thing is written here. T is time, A is the initial concentration, K is the rate constant, and A minus is the X is the concentration at time T, which is this time. Okay. So next is the half-life of a reaction. So what is half-life of a reaction? So when we keep the concentration, initial concentration to half of its value, then the time required to move to that concentration is called half-life. So we have seen this in the previous class also. Now the important thing is that for the first order reaction, the half-life is given by T half is equals to 0.693 by K. Miss in T half is what? This is the time in which your initial concentration will move to the half of its value. Okay, so suppose you are starting from 4 more liter per second, then your final concentration should be 2 more liter per second. Okay, second most important thing about this is independent upon of the initial concentration. See, all of the values are constant. Okay, 6.09693 by k, and there is no initial concentration term. Whereas in case of your half order reaction for the half life for the zero order reaction, there was a dependence of the half life on the initial concentration also. Okay, so it was directly proportional. We have seen that. Okay, so what is the unit for the rate constant? So it is per second. You can directly see it from the rate law, that rate is equals to what? Rate is equals to k multiplied by concentration raised to the power 1. Now mole per liter will get cancelled out, and you will get per second. Now for any half-life period, we can say in general that T half is equals to a to the power n minus 1. Okay, but this is true for all, okay, except this one. So you will get sometime anomalies, that is a different case, but in most of the time your T half is directly proportional to 1 by a minus a to the power n minus 1. So if you put 0 here, then T half will be directly proportional to initial concentration. If you put 1 here, then it will be directly proportional to sorry, it will be have no dependence on the concentration A, because we have put 1 here, right? If you put 2 here, then T half will be inversely proportional of the initial concentration. Okay, so this is a very important equation. You can use it in the various numericals also. So same thing is written here, that A is the initial concentration and N is the order of reaction. So you must remember this equation for the dependence of T half on order of reaction, okay, and initial concentration, right? Next, next we have a first order gas phase reaction. So what is gas phase reaction? Gas phase reaction is what? In which all the reactants and products are almost gaseous, or means there can be some solid substances also, but this reaction is mainly dependent upon the gaseous molecules. Suppose there is a decomposition reaction where A is going from B plus C, means two of the products are formed. Then in that case your K can be written as 2.303 by T log P naught by 2 P naught minus T. Okay, log P naught by 2 P naught minus T. So what is P naught? P naught is the initial pressure and Pt is the pressure at time t. Then we have the second order reaction. So the second order reaction is said to be second order when the concentration have two terms, or you can say when the concentration is raised to the power 2. So again, the rate equation can be expressed in this way. So I have directly written the integrated law, which is K is equals to 1 by T x by multiplied by A minus x. And in this case, one thing should be noticed is that in this case your both the reactants, okay, means if you're taking two reactants, in that case your both the reactant will be same, or there will be one reactant but its power will be 2, means it is being assumed that both of the reactants are same. Until and unless this is not assumed, you cannot arrive at this equation. You will get a different equation in case of different reactants. So what is the unit of second order reaction? So it is per mole liter per second. Again we have used the formula, which is what? Which is 1 minus n, that is 1 minus n will give you minus 1, then n minus 1, that is 2 minus 1, which will give you 1, and per second will be as it is. Next we have third or higher order reactions also, but this type of reactions are very rare, because we have seen that what is order? Order is basically the molecularity for the elementary reaction, and you know that molecularity is very difficult to be greater than 3, okay, or even equals to 3 is very difficult thing for to happen. Why? Because in molecularity the definition says that we have to collide the molecule. So the number of maximum molecules that collide together to give the product is called as molecularity, but the probability that three molecules will collide at the same time, and that also with a specific orientation, so that things become quite impossible. So for that reason we often see second order reaction only, but third order reaction is very less probable. So sometimes the rate of reaction decreases as the concentration of the constituent is increased. Such reaction are called as negative order reaction. Examples are transformation of ozone into oxygen. So it is saying that in many cases your reactant concentration increase can lead to the decrease in the what? Decrease in the rate of reaction. Uh, so why is this? So because order can be anything, right? We have seen this initially also, that it can be fractional, it can be integer, it can be 0, or it can be even negative. So you don't have to be confused in case you get a negative order, because it is also possible. So this is the rate law for the ozone, means for the negative order reaction. This is the example. So we are starting from ozone and it is giving us O2. You can see that this reaction is minus 1, means it is having order of minus 1 with respect to oxygen concentration. Okay, so you can see it very clearly that rate is equals to K multiplied by ozone concentration raised to the power 2, and oxygen sorry, and oxygen concentration raised to the power minus 1. Which one of the following, when one of the following in present in excess, the second order reaction conforms to the first order reaction, and such reactions are called zero order reactions. So basically what happens, we have earlier said that this order of a reaction can change depending upon the pressure, concentration, or temperature, right? So what are we doing here is we're playing with the concentration, and we are increasing the concentration of one of the reactant to an excess amount. Now this raise of concentration to the excess amount plays an important role in determining the order of reaction. So what happens is that since there is a large amount of reactant present, so if a small amount of this is consumed, then the change in concentration looks almost negligible, and we could means see that it is the order of reaction is almost independent upon that concentration. So let us take the example. Suppose this is the hydrolysis. Okay, this is hydrolysis of ester. So we are doing it in excess amount of water, but here water is present in excess, so its concentration change is almost negligible. So its order means its rate is independent of this water concentration. Okay, so what I want to say is that in real terms this is a second order reaction, but due to the change in negligible change in concentration of water, it looks like a first order reaction. So it is also called pseudo unimolecular reaction or pseudo first order reaction. So you can see very clearly that rate is equals to K multiplied by ester concentration. Okay. So we have taken the concentration of ester only and not the water. Next is the temperature dependence. So we will talk about more. So it is a general statement that has been made here. It is said that if you raise the temperature by 10 degrees Celsius for any for most of the chemical reaction, not for any, for most of the chemical reaction, the rate is nearly doubled. Okay. So when we say the rate is nearly doubled, then the rate is doubled for both the backward and forward reaction. So if someone is saying that okay, this rate is doubled, then why should the exothermic reaction go faster? So see, maybe the forward reaction is exothermic, but the backward reaction is endothermic. Now both of the rates are doubled, and since the reaction is exothermic in the forward and endothermic in the backward, so backward reaction goes faster than the forward reaction. So what I want to say here is that rate of reaction increases upon increasing the temperature, and that is very obvious. But now it depends upon the thermodynamic stability and kinetic stability, that what will be formed. Okay, so if it is exothermic, then the backward reaction will be more enhanced. If it is endothermic, then the forward reaction will be more enhanced. But in both cases, the rate is enhanced. Okay, so this thing should be remembered, that for every 10 degrees Celsius rise in temperature, the rate nearly doubles. Now this thing which is called temperature coefficient, so this is 2 for this case, because it is basically the amount of rate change that has been occurring upon increasing the temperature by 10 degrees Celsius. So since it is doubling here, so we say that the temperature coefficient is 2. Now this value can lie between 2 to 3 also. So most of the cases it is seen that 2, but they can vary from 2 to 3. Next is the REDS theory. So the RNS theory was mainly developed to explain the dependence of temperature, okay, temperature dependence of the rate of a chemical reaction. So this is explained by the equation which is given as K is equals to A e to the power minus EA by RT. Okay. Now this A is what? A is the RNS constant or the frequency factor. EA is the activation energy. R is the gas constant. T is the temperature, and K is the rate constant, which of the rate law. So this is the equation that is very important for solving numericals, and it is also called frequency factor, or sometimes it is also called as pre-exponential factor. Okay, so if you keep the temperature to infinite, then your K will be equals to A. Okay, so this is in terms sometimes also called what? Specific rate constant. Now we're looking at the graph. So this is the graph that we have. So what we have done, we have taken log on both sides. So what will this equation turn to? So this equation will turn to log K is equals to A log A minus EA by RT. Okay, Y is equals to MX plus C. If you compare it with this equation, then Y will be this. Okay, M will be this, X will be this, and the intercept will be log A. So that will give you a straight line, and the slope is negative because this term is always positive. This is already a constant, and this is all a constant number. So putting a negative sign against all this positive value will give a negative slopes. Therefore, the slope is decreasing accordingly. And this is very obvious because K is what? K is plotted against 1 by T. Log K is plotted against 1 by T. So if your temperature will go down, your rate will decrease only. Now, what it does, how does we arrive at this theory? So Arrhenius has taken the intermediate or the activated complex to explain this. So he said that before the formation of the product, intermediate or activated complex formation takes place, and it is based on two theories, that is your collision theory and your transition state theory. So we will focus on collision theory later on. This transition state theory is not much of concern. So since k is equals to a e to the power minus ea by rt, ea is positive, k always increases with temperature. So we have discussed it already. Now due to this rate always increases with temperature, whereas the reaction is exothermic or endothermic. This point is also discussed earlier, that the rate of reaction will increase. Now it will depend upon the exothermic or endothermic process that the product will be maximum or the reactant will be formed maximum. Now when t tends to infinity, then k is equals to a and the rate constant becomes equals to Arrhenius or frequency factor. Now this is a very important thing, that for a free radical reaction Ea is equals to 0. Why? So we will study what is Ea. Now I am giving a short brief of that. So it is basically the minimum amount of energy so that the reactant can go to the intermediate before moving to the product. Now since your radical is very reactive, so even a small amount of energy is good enough to give the product. For that reason, your activation energy is quite low for a free radical reaction, and in that case your k, thus k is equals to a and k becomes independent of temperature. So whatever be the value of your temperature, it will not decide the value of k. K will be totally equals to a. Next is activation energy. So what is activation energy? As I have discussed earlier, so it is basically the amount of energy that is absorbed by the reactant to make the reaction feasible, and it is represented by Ea, where A is in the subscript. So this is your graph. Now this graph has two things to be discussed. So first thing is that this is the normal pathway that we have. Okay, this is the normal pathway that we have. We have not applied any catalyst along with it. So we are starting from the reactant, moving on to the where intermediate, and this is giving us the product. Now the difference in the energy between the reactant and the intermediate is called as the activation energy. Okay, and since we are doing it without catalyst, so it is written without catalyst. We will see what happens when we introduce a catalyst here. The second thing is that the difference between the reactant's energy and the product's energy is called the enthalpy of the reaction. So you can see that reactant is a higher energy and product is at a lower energy, so this will turns out to be exothermic reaction. Now activation energy does not depend upon volume and pressure, but it do depend upon the catalyst. Why? Because see, this is the activation energy without catalyst, but as you do introduce a catalyst, the activation energy decreases. Now the reactant has gone through a small energy change for to get the product. So this is the basic role of the catalyst. What it does, it uh, creates a different path, and that path requires less activation energy for the reaction to occur. So for going to A to B, it is quite visible that your delta H is less than 0 and it is an exothermic reaction, and enzyme is catalyzing the reaction much faster than the metal catalyzed reaction. So enzymes are very much specific, as well as they are very much efficient. Means a small amount of enzyme can do a large amount of work, and that also in a very efficient way. Okay, because its mechanism is very complex, at the same time it is very detailed. So it acts upon its reactant very efficiently. So due to this reason, it is much more reactive than the metal catalyzed reaction. Now what is threshold energy? So threshold energy is independent of temperature. Okay, but this Ea is dependent on temperature. So Ea is what? So Ea is the energy difference between the reactant and your intermediate. So if you increase the temperature, the reactant energy will increase, and hence this difference will go down. Okay, this difference will go down and your activation energy will become less. Whereas the threshold energy is not dependent upon temperature, right? Okay. Next. Next is calculation of activation energy. How can we calculate activation energy? For that, we have taken the equation, first of all, we have taken ln against it. So taking ln against it moves ln e to 1. Now, if we take it at two different temperatures, that will give us two different rate constant. So we are writing it as equation 1 and equation 2. So if you subtract both of this equation, A is common. Okay, A will get cancelled out. So remember this. So when at two different temperature, the value of A will be same. So that will result in this equation. If you just simplify this further, you will get the final equation as ln k2 by k1 is equals to Ea by r 1 by t1 minus 1 by t2 under braces. So further, you can just simplify it if you want it. Now, here one thing is to be noticed that we have taken T2 greater than T1. We can take T1 greater than T2 also, that will automatically be counted by this K2 by K1 value. Now this relation is very important as it is used to calculate the rate constant at a temperature by knowing the rate constant which is given at a different temperature. So it is very important equation, and numericals are very often asked from here. Now if you just differentiate that equation, you will get this, and if you take log of that, then you can get this also. So here it 2.303 because we have taken log. Now this same graph has been plotted here also, log k versus 1 by t. So it is a more detailed one because we have taken a sample here, and your equation is also given. So this is y, this is mx, and this is c. You can see very clearly that this is your mx and it is negative, and this is the intercept. Means if you just calculate the distance between this and this, then this distance is equals to what? Log a value. And if you know this, you can calculate your a from here. Further, your ea can be calculated by multiplying your slope of the say this given curve with minus 2.303 r. You can easily get your ea value. Next, I have said you we will talk about this collision theory in the start and also. So let us talk about this. So for that, what we do is that we assume that all the molecules that are present for reaction in the reactant side are of sphere shape and they're hard spheres, and reaction only occurs when they collide with each other. Now collision through which we get the product means there are many more collisions occurring, but there are only some collisions which are giving us the product, and that collision is called as effective collision. And this collision must be such that the minimum energy or the threshold energy requirement should be met. Then and then only your reaction will occur. So threshold energy is what? It is activation energy plus the average energy of molecules, that is of the reactant. Okay, so this is the threshold energy or the total energy. Means you are starting from the zero energy and moving on to the energy of the intermediate or the transition state. So if you just include this thing here, which is your collision factor, then it can be written as, your same equation can be written as k is equals to zab e to the power minus ea by rt, where zab is the collision frequency or the number of say collisions per second between A and B. Second thing that is also very important is that the steric factor. The molecules will collide with proper energy and with the proper steric orientation also, or the reaction will not be giving a product if you don't meet these two requirements, that is energy requirement and a steric requirement. So this was all for theory session. Now we'll move to the question part. Okay, students. So now we'll move to the question part. So today is the question part 2. We have done it earlier in the question part 1, the question that are related to the previous theory. So there will be some questions from the previous theory also and from the today's part also. Disclaimer: the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. So, what are the number of questions? So, there will be 9 to 15 questions. So, that will conclude total of 7 questions. Okay. So, 7 questions will be there. So, let us start this session. Before this session, I would tell you that I will tell the question, explain to you some part of it, and we will given time to solve it. So, let us start the today's theory session. Question session. So, the question says that the rate constant of a zero order reaction is uh, A k is equals to C naught by 2t, B k is equals to C naught minus Ct by t, C k is equals to ln C naught minus Ct by t, and D k is equals to C naught by t. So basically you have to see and tell that what will be the formula for k. So it is obviously from the integrated rate law. You have to directly put that equation. You will easily get the thing. So you have 30 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So first of all, question was very simple. You have to see for a zero order reaction the expression for k. So for those who have solved, the correct answer is C naught minus Ct by t. So we know this is the differential rate law for a zero order reaction. What do? We first of all change the coefficient or rearrange the coefficient accordingly. So this is the a naught term. We have moved it on this side, but since it is having a power of 0, so it will uh, contribute to 1. Now k dt is put on this side. Integrating this will under proper limits. So we have taken proper limits. What are the limits? That time will go from t is equals to 0 to t is equals to t seconds, and our concentration will go from C naught to Ct. So dA integration will be concentration itself, and since C naught minus Ct will be done, so it will give you this, and t minus d0 will give you 2. Therefore, k is equals to C naught minus Ct by t. Now, moving on to the next question. Question number 10. The rate of decomposition of NH3 on platinum surface is 0 order. What are the rate of production of N2 and H2 respectively? Your K is given as this much. Your options are A, so 2 values are given, B, C, and D. So 4 options are there. So let us see who can solve it. So you have 30 seconds to solve this question. Your time starts now. Okay, Shweta, very good. You have solved it. So let us see for this question, right? So moving on to the question again. So what is being given? The rate of decomposition is given. Okay, means the whole reaction rate is given. Now you have to find in terms of N2 and H2. So for those who have solved, the correct answer is C. So this is our equation for the decomposition of NH3. So we have taken the reverse of the formation of ammonia. Now we can write rate is equals to, this thing I have already told you, that rate is equals to minus 1 by 2 dNH3 by dt. Since your coefficient is 2, we have divided this by 2. Here is our coefficient 1, so we don't need to divide it by anything. Negative sign is for reactant and not for product. And here your coefficient is 3, so we have divided by 3. So change in concentration of H2 by dt. Next, it is being given that it is a zero order reaction and your rate is also given. Clear? So if you put this thing minus 1 by 2 dNH3 by dt, this thing will become 2.5 into 10 to the power minus 4. Why? Because rate is equals to k nh3 raised to the power 0. So we can we have the k value. So we get the rate same as the value of r. If you put the rate value here, then you will get this thing. Okay. Now if you just simplify this further, then you will get for dn2 by dt also, because this has been asked the rate of production of n2. So it will be dn2 by dt. Just equate this, you will get as it is. Now what about dh2 by dt? For that you have to multiply this 3 with the given value, and that will give us 7.5 into 10 to the power minus 4 mole per liter per second. Okay, moving on to the next question. Question number 11. The rate constant for a zero order reaction is 2 into 10 to the power minus 10 mole per liter per second. If the concentration of the reactant after 25 seconds is 0.5, what is the initial concentration? So the options are A 0.5 m, B 1.25 m, C 12.5 m, and D 1.0 m. So you have 30 seconds to solve this question. Your time starts now. Okay, let us see the solution. So this was your question, right? So you are given a zero order reaction. Rate constant value is also given. So you have to see that what is the concentration at of the reactant after 25 seconds. So this thing is also given. Okay. So concentration after 25 seconds is also given. So what is the initial concentration you have to find? So the correct answer is D 1.0 m. So this is your rate law for a zero order reaction. Okay, if you just put this thing here, then x1 minus x2 by dt is equals to 2 into 10 to the power minus 2. Now this thing is given 0.5. Okay, this is given 25. 2 into 10 to the power minus 2. You can find x1 easily from this equation, and that will give you 1.0 m. Now here we have used the differential rate equation. You can also use your integrated rate equation to solve this. So try this by yourself. So last question for today's session. So the time for half-life period of a certain concentration going from A to product is 1 hour. When the initial concentration of the reactant is 2 mole per liter, how much time does it take for its concentration to come from 0.50 to 0.25 mole per liter if it is a zero order reaction? So these are the options. So you have 30 seconds to solve this question. Your time starts now. Okay, let us see how we can solve it. So first of all, what is being given? We are given the half-life period of the reaction, which is 1 hour, and the initial concentration is also given. Now you have to find that how much time does it take to start from 0.50 to 0.25. So the correct answer is C. So we know this is the half-life for a zero order reaction. Your T half is known, your A naught is known, you can get your K. So that gives your K as A naught minus A by T or 0.25. Sorry, that gives your K as 1. Now putting this value of K here, we can find the time that is required to do this transition from 0.50 to 0.25. So that will give you 0.25 hour as your correct answer. So this was all for your question session. Thank you.